Hey guys, welcome to our video lesson where we're going to be introduced to how to solve exponential equations using logarithms. So our learning target is I can solve exponential equations using logs. When we're solving exponential equations using logs, what we've done in the past is we've rewritten both sides of the equations with a common base, but we can't do that all the time. So we actually have to change it to log form. Now, this is my first method I have here in this box and what we can do to solve this equation. We also have another method, which is taking the log or natural log of both sides, but that's not our main method, so I'm going to talk about that in class just briefly. And if method 1 doesn't work for you, we can always explore that method. So I have this equation 2 to the x equals 7. Obviously 7 is not a power of 2, so I couldn't just write this using common bases. So because it's already in exponential form, my base and exponent are isolated. What I do next is I change this to logarithmic form. So this would be the log base 2 of 7 equals x. And here comes in that change of base property we learned yesterday. So when I use change of base property, that means in my calculator, I'm going to type the log of 7 and divide it by the log of 2. And that should give me my answer. Let's see here. The log of 7, close my parentheses, divided by the log of 2. And I'm going to round to the nearest thousandth, which would be 3 decimal places. So that'd be 2.807. Okay, so this is approximately 2.807. Okay, so let's move on to some of these examples down here. Same instructions, let's look at letter A. I have 12 to the x equals 31. Okay, so we also just have a plain exponential equation, nothing to get rid of in front of that 12. So the first thing we do is change this to log form. So this would be log base 12 of 30 equals x. So we're going to use a change of base property. X equals the log of 30 divided by the log of 12. All right, here we go. Log 30 divided by log 12. That's approximately 1.3689 if we round correctly. So 1.3, what did I say? 369. Okay, here we go. 369. All right. Now, what's special about letter B is it's e to the x equals 97. So if I change that to log form right off the bat, without thinking of what this is, that would be the log base e of 97. Well, we know the log base e is natural log. So we don't even have to use the change of base property when our base is e, because that's the natural log. So when we go to our calculator, we just type the natural log of 97. And that's approximately 4.575. Okay, and finally, this is the last problem we're going to do in this video. I have 10 to the x equals 68. So when I change this one to log form, that's a base 10. Log base 10 of 68 equals x. I also do not have to use the change of base form here because this is base 10, which is really just the common log. So I just have to type the log of 68 in my calculator. And that's approximately 1.833. Okay, so I hope you see that once we get an equation down to just exponential form, as A, B, and C already were, we just change them to log form, and we can solve from there. If you look down at the next examples, not all of these, in fact, most of these have some work to do to get them into exponential form before we can do that. So that's what we're going to get started on in class. All right, guys, have a wonderful night.